Okay, so here's the thing that kind of broke my brain this week. The most powerful AI systems we're building right now, they might be evolutionary dead ends. Like perfectly optimized, completely sterile, unable to grow.
Which sounds dramatic until you actually look at the architecture.
So let's back up. Because when most people hear AI is dead, they think like the robots aren't working or something collapsed. That's not what we're talking about.
Right, right. We're talking about something more structural, more quiet.
Yeah. So there's this idea that's been floating around research circles that the way we train large language models today creates systems that are frozen, fixed at a point in time. They learn everything they're going to learn during training, and then that's it.
The weights get locked.
Exactly. And the thing is, that works great. These systems are incredibly capable. But the question is, capable of what and for how long?
Because the world keeps moving.
The world keeps moving and the model just doesn't.
So here's where it gets technically interesting. The way transformers are trained, you're doing this massive optimization process, gradient descent over billions of parameters. And the goal is to minimize loss on a fixed dataset.
Which means you're essentially, what, compressing the internet into a snapshot?
Kind of, yeah. It's more like you're building a very sophisticated statistical map of human knowledge up to a certain date. And the map is incredible, but it's still a map of then.
Right.
And here's the counterintuitive part. The better you get at that optimization, the worse the problem can get, because you're more tightly fitted to a fixed distribution.
Wait, really? So being better at training makes you more brittle?
In a certain sense, yeah. There's this trade off. The more you specialize a system, the less it generalizes to things it hasn't seen.
Okay, but hold on. People will say, we have RAG, we have tool use, we plug in real time data. Doesn't that solve it?
So that's okay, that's a great point, and it kind of doesn't. Because what you're doing with retrieval is patching the outputs. You're not changing the underlying model. The reasoning patterns, the conceptual structure, that's still frozen.
It's like putting new fuel in a car that has a 2023 engine map burned into the ECU.
Yeah, that's actually a pretty good analogy.
I'm occasionally useful.
The deeper issue is something called catastrophic forgetting. If you do try to keep training these models on new data, they forget the old stuff. They forget the old stuff, like aggressively. The neural network just overwrites previous patterns to fit the new ones. There's no stable accumulation, which is so different from how humans learn. Completely different. We have, we don't fully understand it, but there are mechanisms. Sleep consolidation, sparse coding, the hippocampus playing this weird role of like temporary storage before things move to cortex. Right, and none of that exists in a transformer. None of it. A transformer is one giant flat optimization surface. Beautiful, powerful, but flat. So when we say evolutionary dead end, we mean it literally. Like in biology, a dead end isn't something that failed. It's something that was so well adapted to its environment that it couldn't adapt when the environment changed. The trilobite was incredibly successful for 270 million years until it wasn't. Until it wasn't. And there are people working on this, right? Continual learning, neuromorphic stuff. Yeah, there's a whole field. Elastic weight consolidation, progressive neural networks, memory augmented architectures, but none of it scales the way transformers scale. Yet. Yet. So, what does this actually mean? Like, practical? I think it means we're in this weird moment where we've built extraordinarily capable systems that have a kind of expiration date baked in. Not because they'll break, but because the world will drift away from them. And the danger isn't that they fail loudly. Right. The danger is they keep working. They keep answering confidently. But the answers are increasingly about a world that doesn't exist anymore. That's the part that gets me. It's not a crash, it's a slow divergence. And we don't have great tools yet for knowing when that divergence has gotten dangerous. Which means the real work, the unsexy, unglamorous work, figuring out how to build systems that can actually learn without falling apart. Which is, kind of the whole problem of intelligence. Just the whole problem. Maybe. I'm Nova. And I'm Alex.